Good morning, learners. We are going to learn about levels and BPP in an image. This is a very small but a very important topic in image processing. Now, let's say we are given an image and we are already given the BPP of that image, that is bits per pixel. How many pixels will be used to represent that image? So, in this case, it is given that BPP is 3. If 3 bits per pixels are going to represent the image, the number of levels means the number of colors in that image will be calculated by using the formula levels is equals to BPP. So here, when the BPP is 3, levels are 8. 8 levels means the color black always is identified by or recognized by the number 0. So 0 becomes the black color. The number which will represent white is always calculated using the formula L minus 1. So in this case, since the levels are 8, the white color will be represented by 8 minus 1 is equals to 7. So you can see a gradient here. 0 is complete black, 1 is less of black, 2 is more of grey, 3 is more of grey, and these color shades are reducing, and 7 is completely prominently white. So more is the BPP, more are the levels, more will be the numbers that will represent colors between black and white, more grey shades we will get in a grayscale image. And if the BPP becomes 0, so levels become 2, there will be only two numbers which are 0 and 1. 0 for black color, 1 for white color, which then the image will become a black and white image. So when the BPP is more than 0, any image becomes a grayscale image. This is also a point to be noted here. And here we see this, there is an image here with different numbers and the levels are not given in this image. So since the levels are not given in the image, we can definitely find the levels out. How to find the levels out? It's a very easy process. If you understand, we'll find out what is the largest pixel. So we'll identify it, the largest pixel. So I can clearly identify here that 99 is the largest pixel. So now since 99 is the largest pixel, we have to identify what will be the levels. So we start comparing 99 with this value, which is 2 raised to power BPP minus 1, okay, or 2 raised to power BPP. So we are looking at the BPP, which will be able to encapsulate the number 99. So 99 should lie in the range of 0 to L minus 1 or 0 to 2 raised to power BPP minus 1. So if the BPP becomes 5, so the range will become 0 to 31. 0 for black, 31 for white. If the BPP is 6, the range will become 0 to 63. Now remember that why it's not 64, why it is L minus 1. Because we are starting numbers from 0, so for levels till 64, the numbers will be 0 to 63. That's a basic mathematical concept here. So again, 2 raised to power 7 is 128. So 0 is black. What is white color? 127. So now 99 can lie in this range here, where 0 is black and 127 is white. So we say that since 99 can lie in this range, the BPP of this image here is 7. BPP is 7. Numbers of levels are 8. We already know black is represented by 0. What will be the white color? BPP minus 1 or levels minus 1, which is 128 minus 1, 127. So we have successfully identified the BPP here as 7 and levels as 8. We'll look at little more examples. Again, this is a similar image, not the same image. In this, we can see that the highest or largest pixel is 127. We'll repeat the same process. So we get here where 2 raised to power 6 is 64, 2 raised to power 7 is 128. So 127 has to lie between 0 and 127. Does it lie between 0 and 127? 127 should be between 0 greater than 0 or 0 and greater than 127 or 127. So here it is the number exactly is 127. It is a complete white pixel. So here again the levels will become 7. Sorry, the BPP will become 7, the levels will become 128, white color representation will become 127, which is L minus 1, levels is 128. Now let's look at another example here. So here the largest identified pixel is 128. So again 2 raised to power 6, 2 raised to power 6, 64. 128 does not lie in this range. 2 raised to power 128. When 2 raised to power 7 is 128, you see L minus 1, which is the white color, will be 127 because basic mathematical concept, the numbers are starting from 0, so the last number will be one less than that number. Let's say we are counting from 0 to 10, so we start from 0, end at 9. Here, similarly, we are counting from 0 to 128, so 127 will be the end and not 128. So this is also not the BPP. So 2 raised to power 8 we check, 256. Yes, 128 does lie between 0 and 255. It is less than 255. Hence the BPP here will become 8. Levels will become 256. White color representation will become 255. Now let's look at a similar example. Now the largest pixel here we can identify, look at here, is 512. So again we start by considering all the powers of 2. So 2 raised to power is 256. 255 is white, 0 is black. It does not lie in the range, most definitely. 2 raised to power 9 is 512. Again, the trick thing here is, this is 512, so the white color will be represented by 511, 511, and 512 does not lie between 0 and 511. It lies between the next BPP, which is 2 raised to power 10, which is 124. 0 is black, 1023 is white. So 512 is a color which is exactly in between black and white. So the best representation of gray for the BPP value 10. So this was about levels and BPP. I hope this concept is now more clear to you.